I'm Javier Hernanz. I'm from the architecture team at Repsol. We are a multi-energy company. We have a lot of business around energy, and I'm also part of the quantum advisory team, and that's a very curious position, as you are going to see. I'm here as a final user. I've seen very impressive speaks here, telling about technical details and a lot of very interesting things. And I'm going to rise the level to a higher level, not because of technicality, but for use cases and applications of what's being seen here. So, who we are? We are challengers in the first step. We've been using HPC for long years. If you look through Google or wherever, you'll find a big project with BSC, for example, in 2015, the HPC for energy. We have our own HPCs here. They're in Madrid, here in Spain, in Houston, and we had a lot of resources for HPC. And the main thing here was our scientists and our people was trying to look for the use cases, the needs we were not covering, to design solutions for that problems that most of times we couldn't solve using the systems available at that moment. So we are trying to solve problems we already know we are not going to solve in this moment. So in 2018, we start trying to create HPC systems using generic public cloud systems. And 1 year later, we discovered in a point of view and trying to understand better how we were doing HPC and trying to solve our problems, that quantum computing was something to take into care, so something to look and to stay close to. That's 2019. We created an internal group that was not very publicized in the media. That was the quantum advisory team. That's what we have moved along different conferences, documents, giving always our vision to what we want to solve with quantum computing and hybrid computing, thinking about HPC plus quantum. And this team is led by our colleague, Ricardo Enriquez. He's one of our scientists in Repsol Technology Lab. And it's mainly conformed by a multidisciplinary team with people from architecture in my case, science in the case of Ricardo, and data science and intelligence, artificial intelligence. But it's also spread to cybersecurity and other areas of the company. So we are working on quantum since 2020, more or less, in very hard for different projects. And here you can see the two bigger public projects we were working on from Repsol. The first one is Cuckoo, which is the bigger one. We are not going to speak about it today, but it's a quick hint. It's I think the bigger quantum computing project, public project in Spain, to analyze different ways to apply quantum computing to different strategic markets. In our case, Repsol is leading the quantum computing for a sustainable energy ecosystem or something like that. Well, the main thing here I want to to point attention to is that project is used to know what's offering quantum computing and hybridization with HPC, and where are going to use it, when it will be ready, and why should you use it. Where one, you know. On the other side, we start another project. It's more recent. It's QCDI, Quantum Cognitive Digital Industry. It's a very, I don't know the word, pompous name for a project, but okay. Here we are much more focused on testing what we've been learning in previous projects, and not only for quantum computing, but for quantum technologies in general, using quantum communications, cryptography, post-quantum crypto. No, this is the project we are going to speak to today. It's still running. We are almost in the middle of the project. Now we are starting the implementation stage. So till now, we've been defining what we are going to do and trying algorithms in classical ways. And from now, we are going to implement it in real. That's the funny part. So the second main message here is we are an industrial company. We are no technology developers. We are not dealers. We are not providers for anyone. We have a very big IT&D department. We are almost, I think, more than 500 engineers for IT in Repsol. So we are a lot of people doing IT. And we are doing IT for us. We are trying to solve industrial problems. We are trying to solve problems in the best way, taking into account the price, the availability, and how everything solves our problems. So this project, QCDI, was described in this manner. I think it's everything sounding too high. But, well, basically, we focused as part of something we already do. We have an IoT platform, an Internet of Things platform. It's used for one project called Elliot. Elliot is deployed in more than 800 service stations. And we try to improve Elliot using quantum technologies and extreme data mining and all those technologies proposed in the framework of the project. So here you have a video explaining what's more or less Elliot. You can find it in LinkedIn. It's in Spanish, sorry. There's no English version. But this is what we are going to speak out now. This is the consortium of the project. You know, Bosch is leading the project, Enzyme, Vicomtech, Radiant. There are different technological companies and centers for developing the different technologies and approaches. Here you see the work packages divided. The project was divided into, and this is where we are working, where from Repsol we are more interested. And as you can see, there's a very wide compendium of quantum technologies and hybridization technologies. What's here perhaps most interesting is we are, as I said, more or less in the middle, so we have real work to do from now. We are working in quantum ways to adapt our DevSecOps projects, DevSecOps operations to adapt to quantum. We already detected that, and you all spoke about it. Container-based approach is the best one at this moment. So we are focusing everything in a container-based approach, and we are trying to do some kind of hybridization between the quantum-inspired, and the process of the data. I mean, if you see here, we have a lot of IoT nodes. We are incorporating a quantum edge, something quantum-like at the edge, to take the data from the IoT platform and process it as soon as possible, in real time, if it's possible, to have the better data quality possible. And we found different ways to process error data, outliers, missing data, and correcting all that information using different strategies between the edge and what's in the cloud, let's say, more generally. This is a very simple, very simple architecture diagram. I almost erased everything just to explain that here we are going to explore also the possibilities of using post-quantum cryptography, or even quantum communications, in order to secure and a little bit more, not for Elliot, because Elliot is our pilot, it's our experimental toy, but for example, other kind of more sensible sensors, or more critical information on site, or something like that. Mm-hmm. So these lines, green and red, depicts a little bit of those critical paths for distributing and creating containers from the cloud and distributing to the edge. Well, I think one of the most interesting things we have in Repsol is what we have evolved from 2017 or something like that, creating different product groups, creating a way of work for everything at the IT department, IT and digital department, and basically providing tools to everyone to work the same way and to don't touch anything. The key for us for the hybridization, the key for us to do things right is at the beginning, we are not going to develop anything, but we are going to use all the resources we have available for us. It not depending on if it comes from Azure or AWS or wherever. So we are a multi-cloud company. We are creating scripts and pipelines and ways of work that are cross. You at the beginning don't need to know where is going to be deployed your project, because the tools created are the same. And of course, there are zero human interaction with the systems. All the systems are through are controlled and deployed and compiled through scripts and tools we've been creating for years. So if you are using, for example, Azure container service or container registry, you are not going to take the Azure container registry directly. You are taking a piece that it's called Repsol container registry that implements the container registry for you, but taking into account virtual networks, cybersecurity, keywords, and all those information that you are going to need but not always is taken into account when you are developing your own solution. So it's a way to create different packages as you are going to need it, as you are going to use it, and doing one thing once and use it all the time, all the rest of the time. We have 5 environments in general. Some structures that are more or less complicated may have less, but always at least 3 different environments. And any one of these environments, lab, dev, test, acceptance, and pro, are authorized to use directly by users. So I think this is the most important thing we have in Repsol. We have those pipelines deeply connected with tools deployed by our cybersecurity teams to check statically check the code, looking for passwords, looking for bad practices, looking for everything. And when you create a product, when you create a software or whatever you want to launch in cloud, because we are mostly cloud, the code and the pipelines are going to be the same. You are just changing a letter in the pipeline to deploy the product, to decide where is going to be installed your application. So I think I've spoken about everything. And well, speaking about the DevSecOps we implemented, I have to say it's hardly followed by everyone. It's imposed to be used by everyone. And you can see here another aspect very important for us in this way of working. I've said, for example, for using small pieces like Azure Container Registry, you have small pieces that overlap the piece, but we have a lot of platforms. Here are just a few of them. We have much more platforms that are controlled, operated, and developed, maintained, and evolved by specific groups that control everything on that platform. So, for example, in Elliot, you saw we are using the IoT platform. We are using Area, which is our advanced Repsol intelligence and analytics platform. Hey, I know it. We have our ML lab with its our own packaging of Databricks with Jupyter tools for the development part, but not for the deployment or execution or production environments. We have our own implementation of container as a service inside our house. So by using different pieces from different clouds, we have a big project for about 2 years to build our own container as a service in order to have it ready for whatever it's needed. We are using the platform as a service packaged, wrapped from the different clouds. And of course, sometimes we need to use infrastructure as a service when we want to do something much more special like HPC. You have to create specific structures. You need to define availability groups with very close. You have to specify that the machines in that cluster need to be connected with InfiniBand. You have to define a lot of details that you only can specify from the IS platform. So we are working in quantum solutions. We are right now creating quantum solutions over that part, taking a little bit or what's needed in its case of those platforms. And here the quantum solutions word is another important term Ricardo coined for us, that is a combination of a problem with a specific problem, with a specific algorithm and a specific hardware to solve it. The same problem can be treated different ways. You can try to solve it using an annealer or whatever, but the formulation, the modeling, the implementation, and or what you want or what you can expect from different approaches is different. So we are not thinking of use cases, that it's too general for us, but for quantum solutions, that is more than the use case. It's the use case, how I'm going to solve it, and where I'm going to solve it. And this is one of those terms we are working on. Speaking about hybridization and I thought I was going to speak a little bit, and I have 4 hours here. For example, in external data mining, this is the process we are going to process the data, to enrich them, to process it, and to have it with good quality. Is the core for the hybridization, because we are going to implement it at the edge as part of the quantum edge, using quantum-inspired algorithms, using tensor networks on GPUs, and some part of those learning processes are going to be run on the cloud with different approaches, and that's why there's a quantum computing as a service connected out there, because we think actual quantum computing is going to be good for us in some use cases, in specific cases, and well, in an IoT context is difficult to guarantee connectivity, for example, or any other kind of situations you have to guarantee to access us, and that's why that's connected on the cloud side. But it's part of the same work package around external data mining. And that's all. If you want, I can speak about this a lot. As you can see, it's not very technical, but we can go deeper in everything. So, thanks.
Thanks, Javier, for this kind and very fruitful presentation. So, before giving the word to the audience, I will take the microphone. Next time I will put petrol to my motorbike. I will think about everything that you explained about that, because, yeah, now I know you, and I know that you are working in Repsol and all the things that you're doing, but I didn't imagine the broad things and broad technologies that we are applying for. And also, can you elaborate a little bit more of the last thing that you said about quantum computing as a service that can be applied at different levels?
Yes, and in fact, it can be used for different with different approaches. I mean, I didn't say I was going too fast. That we are thinking about different uses of quantum sensing in the IoT side, and one experiment we want to do is join that kind of sensors with another ways of computing that information. So perhaps it's not going to be, as you saw, draw, because you need some proximity today, but we are testing and we are proving not only the quantum as a service as an abstract idea, but for example, Kilimanjaro is we are waiting for testing their quantum as a service. Very impatient, and there are different scenarios we are thinking about, and well, no, it's not just thinking of one solution for quantum, or no, we are thinking of quantum solutions, and that's going to be very broad.
Okay, thank you. Any question? Yes.
Hi, I would like to understand a little bit more on the use cases. So my specific question is, being Repsol an industrial company, as you pointed out, so what's the benefit? What's the outcome that Repsol expects from quantum computing? To be more specific, what specific use cases do you see for quantum computing that cannot be addressed with so-called traditional computing?
Well, that's a very good question, and in fact, Google offers 5 million for that answer. But in our cases, we have identified some use cases. In fact, when we start working in quantum computing back in 2020 or 2019 or something like that, the first thing we did was an internal scouting to look for those use cases, to understand how was the ecosystem, the quantum ecosystem, the technology evolving, what we wanted, and how we could expect to evolve. And today we have a portfolio of about, I'd say, 20 use cases, ranging from something very specific to something more general. You can imagine it could be used, but today we can't prove it. Today we are not going to change anything for quantum. We are learning. We know the technology is evolving, and it's small today for our problems, but we are still doing internal scouting to look for new use cases and new possibilities to use the technology. Actually, we are strong users for HPC. We think of quantum uses much more like QPU and a resource you can use along with another resources. And I don't know what I was going to say, but more or less that's the answer. We are increasing the maturity on quantum technologies of Repsol to be ready when the technology became viable to run different use cases regarding chemistry, regarding machine learning, regarding optimization, of course. You saw before.
So for instance, simulation problems like the ones currently running on traditional HPC systems, supercomputers, or?
Yes, yes, and yeah.
Okay, thank you. Thank you very much.
I don't know if I can say more details now while we are recording, but yes.
Okay. I'm sorry about the question because I'm so illiterate on quantum computing that I want to understand what this end up with. Okay, thank you.
Thank you to you.
Any other question from the audience? Jordi, do you want to say something? Okay. So I have first time for one more. In the first slide that you shared, we saw a lot of names of different companies. So how can any of us participate in a project with Repsol? Are you opening some calls to participate? Are you participating in some CDT stuff or some European calls? How you collaborate between companies?
Yeah, these two projects are, I think you mean this slide. These are two CDTI projects from public research and development projects. So the consortium was created, the idea was there, and we worked together to join and to focus on results with different approaches and needs. I'd say, call me. I'm ready, and I'm wondering always to do things. We have a very good team wanting to do things. I don't know if we could or not, because we are an industrial company and we have money restrictions. But anyway, let's speak. I think it's the best thing we can do. Listen, speak, and try to work together.
Okay, thank you. So let's thank the speaker.